Most of us are there. All right, since most of us are there, shall we just start?
Yes, ma'am.
Yes, ma'am.
I think we stopped at exercise 8.4. We had started with that multiple choice question. We had done the first two, if I'm not wrong. Am I? Yes or no? Are we to begin with this question?
Yes, ma'am.
Yes, ma'am.
Okay. So let's have a look at this question. Yeah,
I
Rishit,
think we have not started 8.4.
is it? Jatin, you were not there on
So we
Monday.
started 8.4.
Jatin, you were not there on
Okay,
Monday,
oh,
right?
Monday.
Yeah.
Okay, I'm sorry. Okay,
Okay. No problem. The solutions are there in the classroom. Just have a look. If not, ask me.
okay.
So we'll start with this. Okay. Now, let's slowly use whatever identities we know. Okay. We cannot use those cos square theta plus sine square theta identity because they have squares. So here we'll try to use the reciprocal identity. Sec A can be written as 1 by cos A. Tan A can be written as sin A by cos A. Now, do feel free to interrupt me if you do not follow anything. Okay? Now, let us look at each of these expressions. Here, I have two fractions. Okay? Now, whenever I'm adding two fractions, the denominators have to be the same. Thankfully, the denominators are the same. So, we can add them, right? So, I can write 1 plus sin A upon cos A. Look at the other bracket. It also has a fraction, the denominator being 1. Now what am I doing? I am multiplying one fraction by another fraction. So whenever we multiply two fractions, what do? We multiply the numerators together and we multiply the denominators together. Right? Now, look at the numerator now. Isn't it of the form a plus b into a minus b? Yes or no?
Ma'am.
Yeah. So I can write it as a square minus b square. Here a is 1. So 1 square minus b square is sine square a. And cos a into 1 is cos a. Now square of 1 is 1 itself. So I can simply write this as 1 minus sine square a. Okay. Now there are two ways to do this. Instead of this 1, I can write sine square a plus cos square a and the minus sine square a remains. Or you can simply substitute 1 minus sine square a as cos square a. Okay. Now, what will happen in the numerator? Sine square a and sine square a will get cancelled. And what remains? Only cos square a upon cos a. Cos square A can be written as cos A into cos A, and the denominator is cos A. One of them gets cancelled. What remains is only cos A. Do we have cos A in the options?
Yes,
Yes,
ma'am.
ma'am.
Yes,
Yeah.
ma'am.
Option D is the correct option. Okay. You can note it down and then only I'll go to the next question. And let me know when you finish. Do it in your notebook so that your notebooks are not pending. Kaustubh, are you writing? No? Ishita, did you follow?
Yes, ma'am.
Okay. Can we go to the next? Tell me when you all are ready. Those who are ready can try the next one.
Ma'am, done.
Everyone done?
Yes, ma'am.
Yes, ma'am.
Okay. So we'll go to the next one. 1 plus tan square A upon 1 plus cot square A. Start replacing it with whatever we know. We know tan square A can be written as sine square A. You can also use the identity here. What is 1 plus tan square A? Correct?
Six square.
Yeah. And what
Six
is 1
square.
plus cot square A?
6 square.
Yes. But is any of these there in the options?
No.
No. So let us use what else we know. I can write sec square A as 1 upon cos square A, and I can write cosec square A as 1 upon sine square A. Correct? Yes
Yes,
or
ma'am.
no?
Yes, yes.
Yeah. Now what do I have? I have one fraction. I have one fraction upon another fraction. Correct? So I can replace it by a multiplication sign, and I have to reverse the second fraction. So second fraction will become sine square A upon 1. Now what is this? Multiplying two fractions. When I multiply two fractions, I multiply both the numerators together. I multiply both the denominators together. So what do I get? I get sine square A upon cos square A. This can be written as sine A upon cos A, the whole square. Now what is sine A upon cos A?
Tan
Ten.
A.
Tan A. And the square of tan A is tan square A. Do I have it in the options?
Yes.
Yes, ma'am.
Which option is the correct option?
Option
D.
number D.
Yes. Okay. In the brackets, write down the identity used so that you know how you got it. From here, how it came to this point. Is it clear to you?
Yes.
Yes, ma'am.
Let me
Ma'am, the
know when
step
we can move
after
on.
that I didn't understand.
What? Who is that? Sharvari. Yes,
Sharpati.
Sharvari.
Yes. 1
What?
upon cos square A upon 1 upon sin square A. I didn't understand how you
Yeah.
got that.
What happens if I have two fractions like this? What do I do?
No, I didn't understand how you obtained this.
This.
Yes.
Okay. Now, tell me the relationship between sec A and cos A. How are they related? Sec A and cos A.
I don't know.
You don't know? Okay. Then I think we should revise the reciprocal. Sin A is equal to 1 by cosec A and cos A is equal to 1 by sec A. Remember now?
Yes.
Yeah. So that's what I did. When I got sec A, I wrote it as 1 by cos A. But it was square, so I wrote 1 by cos square A. Same way, when I
Okay.
saw cosec square A, I wrote it as 1 by sin square A. Clear?
Yes.
Okay. You should remember the reciprocal identities, all those things. You should never forget. Only then the exercises will become easier. Okay.
Yes.
I think we can go to the next one. Everyone?
Yes, ma'am.
Okay. Now let's have a look at this question. Cosec theta minus cot theta, the whole square. Okay. Now, what does this remind you of? This is the LHS. We have to prove that this is equal to this. So we have now taken the LHS. We have to somehow get this. Okay, that's the idea. Now, what does this remind you of, this expression? Cosec theta minus cot theta, the whole
A
square.
minus B whole square.
Yes, A minus B the whole square. So what is A minus B the whole square?
A square plus B square minus 2AB.
Yeah. Shall we use that? Let's use
Yes,
it.
ma'am.
A square will be cosec square theta plus B square is cot square theta minus 2 cosec theta cot theta. Okay.
Ma'am, is it
Now,
square or is it multiplied by 2?
it is square, children. The PDF from which I copied these questions, it is showing the square as 2. But you have your textbooks, right?
Yes.
Yeah, it is square. All right. Keep your textbooks with you so you will have clarity. Okay. So now you know how I opened the bracket using A plus B, the whole square. Okay. Now I can use identities here. Yes, I can write cosec square theta as 1 plus cot square theta. This one. And the remaining thing as the same. Now, so when I add these two cot square theta, what do I get? What else can I do? Now, tell me. There are different ways to do this question. You all chose this. Tell me further. Can I take 2 cot theta common? Yes or no?
Yes, ma'am.
Then what should I do? Now, my idea is to bring cos. So let me replace my cot theta as cos theta upon sin theta.
Cos theta upon sin theta.
Yeah. This also I will write as cos theta upon sin theta. And 1 by cosec theta can be written as?
1 by sin theta.
Yes. Now look at the bracket. We always sort out the bracket first. Now in the bracket, I have two fractions with the same denominator. So I can write it as this. Correct? Now, look at my expression after 2. I have one fraction multiplied by other fraction. So what can I write? I can multiply both the numerators together and both the denominators together. Then what will I get? 1 plus 2 into, open the bracket, cos square theta minus cos theta upon sine square theta. Then what to do? This is one fraction, this is another fraction, right?
Ma'am, cross multiplication.
Yes, we can cross multiply. Before that, 1 minute, I missed this 2, no? 2 will come here also, right? So what can I write this as? Sine square theta plus 2 cos square theta minus 2 cos theta upon sine square theta. Then what can I write? We have to bring this 1 minus cos theta.
Ma'am, we can
upon
write
1
sine square theta as 1 minus cos square theta.
Yes. Sine square theta is 1 minus cos square theta because everything has to come in terms of cos. So if I write this, sine square theta is 1 minus cos square theta plus 2 cos square theta minus 2 cos theta upon the bottom also as 1 minus cos square theta. Then what?
Cos thetas will get cancelled.
Which cos theta will get cancelled?
In the numerator,
Only one you can cancel, no? This is 2 cos square theta. So you will have 1 plus
Ma'am,
cos
it
square
will be
theta.
of the form a plus b whole square.
Which one? Yes.
The numerator will be 1 minus cos whole square.
Yes, you can do that way. This, and this, right?
Yes.
But
Minus cos square theta plus 2 cos square theta will be plus cos square theta.
after simplifying.
Yes, after simplifying.
Okay. Yeah. Yes. After simplifying, correct. So what will I get? This is of the form a plus b the whole square. So what will I get here? 1 minus cos theta the whole square upon 1 minus cos square theta. This can be written as 1 minus cos theta into 1 minus cos theta upon the denominator can be written as can I?
Yes.
Can I cancel these two?
1 minus cos theta and
And that
upon
is
1
your
plus cos.
RHS. Okay? Now, there's another way to do the same question. Since you all started with this is also correct. We can do it in another way also. In the beginning itself, we can replace it. Like if I start with LHS as cosec theta minus cot theta, the whole square. Here itself, I can write cosec theta as 1 by sine theta and cot theta as cos theta upon sine theta, the whole square. Okay. Now, these are two fractions with the same denominator. So I can write them like this. The whole square. Okay. So now I'll write 1 minus cos theta the whole square upon sine square theta. right? Now, do it in the same way. This can be written as 1 minus cos theta the whole square upon sin square theta can be replaced as 1 minus cos square theta. Now, same way break up like the previous question. 1 minus cos theta into 1 minus cos theta upon 1 minus cos theta into 1 plus cos theta. Cancel, you get the same thing. Did you see that? Okay. So which method seems to be shorter?
Ma'am, the second one.
The second one is shorter. Okay. But both are correct. Only thing is this one is a little shorter. You can easily get it when you replace it by the reciprocal identities. Okay. Both are correct. Whichever you want to write, you can write down.
Ma'am,
Yes.
ma'am, I didn't understand after applying the A plus B identity in the first part of the question when we did it in the first way. More towards the down.
This one?
No, ma'am. Could you please scroll more? Yes, ma'am, over there. 1 minus cos square theta plus 2 cos square theta minus 2 cos theta.
This one?
Yes. After this, I didn't understand.
Okay. We just added these two. See, this is 2 cos square theta minus cos square theta. So 1 cos square theta.
Yes.
Okay. Now this is of the form a plus b into a minus b. Sorry, a minus b the whole square.
Yes.
So we wrote it as 1 minus cos theta the whole square.
Okay.
Understood?
Yes, ma'am.
Okay. So write down whichever you find easier. Which one you want me to keep it on the screen? The first one or the second one?
Ma'am, the second one.
Ma'am, second one.
Okay. The ones who have finished, try the next question. Do let me know when you finish. Done?
Yes, ma'am. Done.
Okay. So shall we move to the next one?
Yes, ma'am.
No, there was third one. This is the third one, no? Now, let's have a look at the LHS and the RHS. LHS has got tan and cot. RHS has got sec and cosec. Okay. Now, look at the hint given. Write the expression in terms of sine theta and cos theta. That means in our LHS, wherever we have tan, we will write it as sine by cos. And wherever we have cot, we will write it as cos by sine. So, tan theta will become sine theta upon cos theta. And the denominator will be 1 minus cot is cos upon sine plus cot theta. That will be cos theta upon sine theta upon 1 minus tan theta is sine upon cos. Okay. Now let's handle one part of the expression at a time. Now look at this. What is this? I have one fraction and at the bottom I have difference between two fractions. So first I have to sort this out. There are two fractions with different denominators. So first I have to make the denominators equal. So we are going to concentrate on the denominators of the, we are going to concentrate on the denominator of the first fraction. So that's what we are going to do one by one. Let's start. Just look at the denominator part. Numerator, keep it as it is. And come to the denominator because it's got two fractions with different denominators. So we are going to cross multiply. So I will have 1 into sine theta as sine theta minus 1 into cos theta upon denominator is sine theta itself. Now let's go to the other one. Same situation in the other one also. Numerator is already sorted. Let's come to the denominator. Same way, cross multiply. So I'll get cos theta minus sine theta upon cos theta. Okay. Now have a look at each one. Here, what do I have? I have two fractions. One at the top, one at the bottom. So I will replace it with a multiplication sign and a reciprocal, right? So what will I write? I will write the first numerator as it is. Denominator, I will reverse. So sine theta will go up. Sine theta minus cos theta will come down. Same way. Next. Cos theta upon sine theta as it is. And other fraction, reverse it. Okay. Now look at your expressions. I have one fraction multiplied by the other fraction. So what do I do? Multiply both the numerators together, multiply both the denominators together. So sine theta into sine theta upon cos theta into sine theta minus cos theta plus same way here. Same way here, cos theta into cos theta upon sine theta into cos theta minus sine theta. Okay. Now multiply. This will be sine square theta upon cos theta into sine theta minus cos theta plus cos square theta upon sine theta into cos theta minus sine theta. Is this much clear to everyone?
Yes, ma'am.
Everyone? Go
Yes,
through the
ma'am.
steps till this much. Go through the steps again. One by one, go through the steps. And note down also till this much. Okay?
Ma'am, just a minute.
Pardon? Someone said something? This much is written down, everyone?
Just a minute, ma'am.
Yeah, no problem. Take your time. It's all about your fractions. You should know how to add fractions. You should know how to multiply fractions. Go step by step, then you won't make a mistake. Harushi is following?
Yes, ma'am.
Oh. Have you written this much?
Yes, ma'am. Done.
Oh. Now, let us have a look at the denominators of both these fractions. One has cos theta into sin theta minus cos theta, and the other one has sin theta into cos theta minus sin theta. Correct? There is reversal. Yes or no?
Yes,
Now,
ma'am.
so if can I make these brackets the same? If yes, how will I make them?
Take the minus sign common.
Yeah. If I take this minus sign common like this, I'll just add a page here. Okay. I'll keep this one the same. Now see what I'm doing. It's all about how you observe things. Take minus sign common. Now if I take minus sign common, my cos theta will become negative and my sin theta will become positive. Correct? So, what can I do? I can bring that minus sign here. And here I can write sin theta into, take the sin first and the cos later. Did you understand what I did?
Yes.
Okay. Now, since both these expressions have this common, I can take this out. 1 upon sin theta cos theta sin square theta upon cos theta minus cos square theta upon sin theta. Got it? Now what do I have in the bracket? I have one fraction subtracted from another fraction. But they are not having their denominators equal. So I have to make their denominators equal. So I'm going to cross multiply. So this part remains the same. It's a little longer question. That's why I did it in parts. I told you to first understand those steps. Now we are going ahead. Now when I'm cross multiplying, I already have sine square theta multiplied by one more sine theta. So it will become sine cube theta minus same way cos square theta into cos theta is cos cube theta. And in the denominator, I can have sine theta into cos theta. Is this clear to everyone?
Yes, ma'am.
Okay. Now we are going to simplify this. How? You all have to tell me.
A cube minus B cube identity.
Yes. Use the a cube minus b cube identity. Now denominator I'm copying as it is. What is a cube minus b cube? Forgot? A cube minus b cube is equal to
A minus B into A square plus B square plus AB.
plus AB, correct? Where our A here is sine theta and our B here is cos theta. So we are going to use this to write the numerator. A minus B means sine theta minus cos theta into sine square theta plus cos square theta plus what? AB. So sine theta into cos theta. Is that clear to everyone? This much? Yes?
Yes, ma'am.
Now what do you observe in the numerator? What do I observe? Can I write 1 instead of this?
Yes.
Yes? Because identity says sine square theta plus cos square theta is equal to 1. So instead of that, I have written 1. Now look at our expression. We have one bracket multiplied by another bracket. So we are going to multiply both the numerators. 1 into this will remain only this. And what will my denominator be? Sine theta cos minus cos theta into sine theta cos theta. This and this will get cancelled. What remains is only 1 plus sine theta cos theta upon sine theta cos theta. Okay. Now, if I have A by B plus C by B, I write it as A plus C by B, right? Same way,
Yes.
I can separate this also. So I can write this as 1 upon sine theta cos theta plus sine theta cos theta upon sine theta cos theta. So this will get cancelled and become 1, and I will have 1 upon sine theta into 1 upon cos theta plus 1. Now what is 1 upon sine theta? Cosec theta into sec theta plus 1. Is that the RHS? Yes or no?
Yes, ma'am.
I know it's a little long. That's why I stopped in between and asked you all to go through. Once again, go through each step. Then continue writing. I know this page you must have written down earlier, yet go through it again before you proceed. Wherever you find you don't understand, ask.
Ma'am, we missed the second question.
Second question we missed. This is
Yes,
the
ma'am.
second one. Oh, we missed it. Okay, we'll do
Yes,
it.
ma'am.
Do the third one, then we'll go to the second. Okay.
Okay, ma'am.
Go through each step of the third question. Revise all identities that you have learned the previous year and the fractions. How to add fractions, how to multiply fractions, how to subtract fractions, how to divide fractions, and the identities. All these you should know very well before you start this chapter. Okay. Go step by step and ask if you don't understand any step.
Ma'am,
Yes.
ma'am, will you just explain that line, how you take that minus sign common?
Here. See, here I observed that the denominators of this have a something in common, but the signs are reversed. So I took a minus sign common. Now, when I took minus sign common, to make this cos theta positive, I had to give a minus sign to cos theta. And to keep sin theta as negative, I had to make it plus in the bracket. So inside the bracket, sin theta became positive, cos theta became negative. Okay, and this minus sign which was outside, I brought it to the numerator. Followed?
Yes, ma'am.
Any doubt? Mahalakshmi is following.
Yes, ma'am.
Good. Nancy,
Yes, ma'am.
Srishti writing,
Yes, ma'am.
Swayam,
Yes, ma'am.
let me know when you finish. You can write down here a cube minus b cube, a minus b into we use this identity to get the next one. Over?
Ma'am, just a minute.
Sure. Is Lloyd writing?
Yes, ma'am.
Yeah. Meet is able to concentrate without Lloyd?
Yes, ma'am.
Okay.
Done, ma'am.
Okay. Now we'll go to the second question. I'll add a page here. Or we'll add a page before this one. Okay. Can you all tell me what the second question is? Any one of you?
Cos A divided by 1 plus sin A
Plus.
plus 1 plus sin A divided by cos A is
Equal to?
equal to 2 sec A.
Okay. So we'll start with the LHS. LHS is cos A upon 1 plus sin A plus 1 plus sin A upon cos A. Okay. That means I have two fractions which are to be added. So the first step is to have their denominators equal. But they are not. So we are going to cross multiply. So let's start cross multiply. Cos A into cos A is cos square A. And this will be 1 plus sin A the whole square upon cos A into 1 plus sin A. Okay. The next step is to open this bracket. This bracket is of the form A plus B the whole square. So A square plus B square plus 2AB. Correct? Upon cos A into 1 plus sin A. Now, what to do next? Think. I need not use the bracket. I can just write cos square A plus 1 plus sin square A plus 2 sin A upon cos A into 1 plus sin A. Then what can I do now?
Sin square theta plus cos square theta is equal to 1.
Yeah, I have cos square theta plus sin square theta, which can be written as 1. And there is 1 already there. So my numerator became this. Why? Because I used the identity sin square A plus cos square A equal to 1. Okay. Now, 1 plus 1 is 2. So the numerator becomes 2 plus 2 sin A upon cos A into 1 plus sin A. Now what can I do?
Ma'am, can take 2 common.
Yes, I can take 2 common. So I will get 2 into 1 plus sin A upon cos A into 1 plus sin A. Now what can I do?
Cancel 1 plus sin A.
Yes, we can cancel these two and I'll get only 2 by
2
cos.
sec A.
Yeah, which I can write as this and 1 by cos A is sec A. So I got my RHS. Clear? Go through the steps. Keshvi, are you understanding?
Yes, ma'am. Yes, ma'am.
Okay. Amrita,
Yes, ma'am.
are you able to follow?
Yes, ma'am.
Okay. Let me know when you're ready to go to the fourth one. Bhumika, done? Bhumika is there or having breakfast? Can we go to the fourth one?
Yes, ma'am.
Yes, I'm writing.
Ishita?
Yes, ma'am. I just need a minute, please.
Okay. Try the fourth one, others. Fourth one is very simple.
Ma'am, done.
Okay. We'll go to the fourth one. Let's start. 1 plus sec A upon sec A. Let's start with the LHS. Okay. Now, how can I write sec A as? How can I write sec A as?
1 upon cos A.
Yeah. So I'll write this as 1 upon cos A and the denominator also as 1 by cos A. Now look at the numerator. I have two fractions to add. So I'm going to cross multiply. 1 into cos A is cos A plus 1 into 1. Denominator is cos A upon 1 by cos A. Now I have two fractions. One at the top, one at the bottom. Okay. Now whenever I have this, what do? I replace it by multiplication. First one as it is. Multiplication. Reverse the second fraction. So cos A goes up. 1 comes down. Cancel cos A. So what do I get? Cos A plus 1 upon 1. Which can be written as 1 plus cos A. Correct? Now, this question, they tell us simplify the LHS separately, simplify the RHS separately. So let's now start with RHS. What is RHS? Sine square A upon 1 minus cos A. Now, I know the identity sine square A plus cos square A equal to 1. Now, if I push cos square A to the other side, I will get sine square A is equal to 1 minus cos square A. That I am going to write here. Okay. So, I am going to write my numerator as 1 minus cos square A upon 1 minus cos A. Now, what to do? Can anybody tell me?
A square minus B square.
Yes. This is of the form a square minus b square. So I can write it as a plus b into a minus b. Okay. Here my a is 1 and my b is cos a. So I can write this as 1 plus cos a into 1 minus cos a upon 1 minus cos a. Now what?
Ma'am, cancel 1 minus cos.
Yes. And what remains? 1 plus cos A. So you saw LHS also became this. RHS also became this. So can I say LHS is equal to RHS?
Yes, ma'am.
Yeah. So some of the questions you can do it this way also. See, जैसे 1 plus cos A आया, we don't know what to do further. So we stopped there and we took the RHS. And we simplified. And ultimately, we got the same expression. So this is another way you can do such question. Understood?
Yes,
Yes
ma'am.
or no? Okay. So we'll stop here. How many questions in this exercise? 8. Okay. So we'll continue tomorrow.
Ma'am, 10 actually.
There are 10. Okay. So the rest we'll do tomorrow. Have you noted down
Ma'am,
the
can
fourth
we
one?
complete it today?
Okay.
Ma'am, can we complete it today?
Complete it today won't be too much.
Ma'am, you can take till 9 at least.
Others, let everyone say that.
No
Ma'am, we'll
problem.
do it tomorrow.
9 o'clock.
Tomorrow. Ishita is like tomorrow. And then others?
Ma'am,
till
tomorrow.
9.
Okay. So we'll have it tomorrow only then. Okay. Because I know it is too much. For those of you who are not very thorough with fractions, they'll take time to understand. Okay. So do it. And those who are interested, the solutions are there. Try on your own, cross check. Do not stop. Jatin, you sit till 9 o'clock and complete it.
Okay, ma'am.
And let me
Yeah.
know. I'm there here. Okay?
Yes, ma'am.
Okay then. Bye everyone. So we'll meet tomorrow, same time.
Bye.
Thank you, ma'am.
Okay.
Bye, ma'am. Thank you, ma'am.
Bye.
Bye, ma'am. Thank you, ma'am.
Bye everyone.